This Zoom session is being brought to you by the Fractal Octaves Z, one of my favorites. Okay, right, for today we finish up chapter 2. So that means that homework is due next Tuesday and quiz 2 will be due the following Thursday. I'll open it up at the end of class. Okay, phase shift. Phase is basically when in the cycle a wave is. So here we go. Let's start with this. Y equals a sine omega x plus phi. A will give you, modulates the amplitude, how far up and down the wave goes. Omega modulates the frequency, how quickly it goes through its cycle. And phi tells you when exactly in the cycle it is. Now, okay, written like this, it's actually more useful to pull out a factor of omega from the inside two terms and get omega times x plus phi over omega. And or in other words, y equals a sine omega times x minus negative phi over omega. So x minus this thing means that the wave is delayed by that much, how much it's shifted left or right. And now, okay, we already knew the period, 2 pi over omega, absolute value of omega. Amplitude is the absolute value of a, and is shifted horizontally left to right by the phase shift minus phi over omega. And similarly, if you have y equals a cosine omega x plus phi, you have the same thing. Amplitude is absolute value of a, period is 2 over absolute value of omega, and the phase shift is minus phi over omega. However, for the sine, it's minus phi over omega is a phase shift from the sine function. For a cosine, it's minus phi over omega is a phase shift from the cosine function. So for the sine, you'd be moving the first 0 left or right. And for cosine, you're moving the first peak left or right. Now, okay, there's some phase shift shortcuts. If you're adding 2 pi, adding and subtracting 2 pi, you get back to where you were. That's period 2 pi. Sine of omega x plus or minus 2 pi is sine omega x, cosine omega x plus or minus 2 pi is cosine omega x. Now, if you shift left or right pi, that's a half period. So sine of omega x plus or minus pi is negative sine omega x, and sine to its opposite. Deal with cosine. Cosine of omega x plus or minus pi is minus cosine omega x. That's the half period. Now, if you add or subtract pi over 2, this gets a little more complicated. It turns sines into cosines. And I had to admit myself that it's going to be a little difficult to remember which is positive, which is negative. Add or subtract pi over omega 2 inside a sine, and it turns into a plus or minus a cosine. Add or subtract pi over 2 inside a cosine, and it turns into minus or plus sine. Okay, and which is minus, which is plus. Okay, there you might have to actually take values and evaluate values and such. But okay, so it's cos omega x or minus cos omega x if you add or subtract pi halves to a sine argument. Add or subtract pi over 2, 90 degrees, to a cosine argument, you get minus or plus sine. That's pi halves phase shift between the two. So for example, okay, here's an easy one. Y equals 4 sine 2x minus pi. This minus pi is a half period in the sine function. So he gets minus 4 sine 2x. Okay, so amplitude is 4, period is 2 pi over 2, which is pi, and it's no phase shift. Now, all right, to graph this, well, I always find sine to be a little more troublesome than cosine because it's not immediately obvious whether it's going down from the origin or up from the origin. Okay, it's easy enough. You set x equal to 0, then sine 0 is 0, and y is 0. And okay, period is pi, so 1 full period later, it's back to 0. Halfway between the zeros at pi halves is another 0. That's easy enough. Now, halfway between the zeros, it's pi over 4 and 3 pi over 4. And the question is it plus or is it minus 4? Well, okay. For here at pi over 4, you plug it in, get minus 4 sine pi halves, and sine of pi halves is just 1. If you rotate by 90 degrees, you get 0 by 1. So sine of pi halves is 4. So you get a negative 4 here because of this minus. So it goes from 0 to minus 4. It starts by going downwards. Then 0 to positive 4, then 0, then negative 4, 0, positive 4, 0. All right. Here we have y equals 2 cosine 3x plus pi over 2. Now, all right, here I'll write it by pulling out a factor of 3 from these two terms inside. 2 cosine of 3 times x minus negative pi over 6. So you have an amplitude of 2, a period of 2 pi over this 3, and a phase shift of negative pi over 6. So if you start with x equals negative pi over 6, you get a 0 here. 3 times 0 is 0. Cosine 0 is 0 times 2 is 2. So minus pi over 6, it's at 2. Period is 2/3 pi. So add 2/3 pi to pi over 6, you get pi over 3. No, sorry, that's pi over 2. So from here to here, you go from 2 back to 2. Half of between minus pi over 6 and pi over 2 is pi over 6, where it's negative 2. Midway between the peaks and the values of the zeros. So midway between pi over 6 and minus pi over 6 is 0, where it's 0. Midway between pi over 6 and pi over 2 is pi thirds, where it's 0. So 2 to 0 to minus 2 to 0 to 2. And then it keeps waving. Now this also goes through 0 by 0, so you could, from here, we could have gone to saying that cosine of something plus pi over 2 is sine, whatever. All right, now, here's y equals 3 sine 2x plus pi over 2. All right. Oh, well, 3 sine. Now, sine of angle plus pi over 2. Well, if you add pi over 2, you get a cosine. So, all right, this will be the same, excuse me. This will be the same as minus 3 cosine 2x. All right, then it's easy enough to work. Amplitude is absolute value of negative 3, or 3. Period is 2 pi over this 2, which is pi. Start at 0 when x is 0. Cosine 0 is 1 times negative 3 makes a negative 3. So it goes to 0 by negative 3. One full period later at pi, it's back to negative 3. Half between 0 and pi over 2 is the other peak, which yields 3, a half period, which is 3. And half of between the peaks and the values of the zeros at pi over 4 and 3 pi over 4, 0 and 0. So negative 3 to 0 to 3 to 0 to negative 3, and then keep the cycle going. Here is y equals negative 3 sine negative 2x plus pi over 2. Okay, now again, adding pi over 2 inside the sign turns it into a cosine. Minus 3 cosine of negative 2x. Now, okay, a negative, well, cosine's an even function, so this negative gets absorbed. Get negative 3 cosine 2x. Amplitude is absolute value of negative 3, and that's 3. Period is 2 pi over this 2, and that's pi. Period pi, amplitude 3. When set x equal to 0, when you set x equal to 0, it's minus 3 cosine 0. It's minus 3. So minus 3 to minus 3 pi units later. Half between 0 and pi is pi halves, where it's a half period, and therefore the opposite y, positive 3. Halfway between the values and this peak are the zeros here and here. 0 between 0 and pi over 2 is pi over 4. Between pi over 2 and pi is 3 pi over 4, where y equals 0, here and here. So negative 3 to 0 to 3 to 0 to negative 3, and then it keeps oscillating. Here we have, now here we go the other way around. Given amplitude, period, and phase shift, write the equation of a sine function. So, okay, y equals a sine omega times x plus phi over omega. Absolute value is 3. Well, really, I should say is plus or minus 3. Maybe you should verify that. 2 pi over omega is 3 pi. So after a little bit of transposition, omega is 2/3. And this is a plus omega over. It's the opposite of the phase shift. So minus pi over omega is minus 1/3. And so you're getting a 3 sine 2/3 of x plus 1/3. And you know, this is a bit ambiguous. This could be a plus or a minus, actually. Maybe it needs a bit more information. Okay, that's it for now.